Sum number 26, page number 233, very important sum, a semi-vertical angle in which you have to find the a cone in which a semi-vertical angle you have to prove it to be equal to alpha is equal to sine inverse of 1 by 3. That is to prove. What is given in the sum? Given, you have to write it on the right side, surface area of the cone is given, which is pi r L plus pi r square. So this S is a constant because that's been given. You are making, using that surface area, you are making a volume as maximum 1 by 3 pi r square h. Volume is maximum means differentiated value will be equal to 0. So how can you differentiate when you have r and h? So write h in terms of r. How do you write that? S minus pi r square by pi r is L and h L r, and h can be written as root of L square minus r square. So it's root of s minus pi r square the whole square by pi square r square minus r square. So when you solve this, pi square r square s square minus pi square r to the power 4 minus 2 plus 2s pi r square minus pi square r to the power 4. Thus you get s square minus 2s pi r square by pi square r square, and take it out of the root, s square minus 2s pi r square by pi r. Substitute that here, 1 by 3 pi r square h ku bala root of s square minus 2s pi r square by pi r. Pi and pi get cancelled, r and r get cancelled. Now you can square both sides. In maxima, minima, you are allowed to square both sides, not in increasing, decreasing. V square is equal to 1 by 9 r square s square minus 2s by r square. Now taking this inside, you can consider V square to be some random z. So 1 by 9 into s square r square minus 2s by r to the power 4. So on differentiation, can you see that s is a constant? Okay. S is a constant, S is a constant, pi is a constant, 2 is a constant, 1 by 9 is a constant. So 1 by 9 eduthu, S square is a constant into 2r minus 2s pi constants 4r cube. So thus dz by dr I have differentiated, but I know that can be equated to 0 because maxima or minima. S2r is equal to 2s pi 4r cube. 2 and 2 get cancelled, s and power get cancelled, r and r square get cancelled, thus you get s is equal to 4 pi r square. Straight go to the top after this, always. So you substitute that 4 pi r square. So 4 pi r square is equal to pi r L plus pi r square on substituting there. Bringing this side, 3 pi r square is equal to pi r L. So pi and pi get cancelled, r and r get cancelled, 3r is equal to L. Substitute this in the diagram, again go back. L is equal to 3r. So sin alpha is equal to opposite, which is r, by hypotenuse, which is 3r, so is equal to 1 by 3, thus alpha is equal to sin inverse of 1 by 3. Now the sum is over, okay, but you have to do a double differentiation test. Why? To prove that its maximum, the volume is maximum. Its question is given that maximum volume. So to ensure its maximum volume, what is where is the differentiated value? Here. This has to be taken and you have to do a double differentiation test. See, which is 1 by 9, s square is a constant, 2 is a constant, differentiation of r is just 1, minus 8 is a constant, s is a constant, pi is a constant, r cube differentiate panna 3r square. So you have to find out whether this is negative or positive, okay. So 1 by 9 2s square, this is 2s square minus it is 24s pi r square. Square, we are taking the differentiate value, differentiating once again, 2s square, because s square is a constant, 2 into s square, r differentiation 1 minus 8s pi 3r square. So this is the differentiate value. To find out whether this is positive or negative, what do we do? You know that how to find out this is negative. How to, because you have maxima, double differentiation must be negative for the value to be maxima, correct? So how to find out this is negative? 24s pi r square. Okay, 2 into s square. Okay, we can take out what is common in this. Let's try. Okay, s is common, so we'll have 2 s. 2 is also common. by 9 is there. So what is left here? Left over is just an s minus 12 pi r square. Okay, 12 pi r square. And how to find out this answer is negative 3r is equal to L. S itself is pi rl plus pi r square, correct? S itself is pi rl plus pi r square. So pi rl plus pi r square minus 12 pi r square. So can you see that pi rl minus 11 pi r square will be there. So when you take out what is common, pi and r, get L minus 11 r. And you know the ratio between L and r, L is 3 times r. So L is 3 times r, 3r minus 11r, thus the answer is negative. See, thus you know the found out answer is only maxima. The sum that you did was for maxima. Okay, this is one sum. The next is sum, the second, I found that double differentiation little difficult. I hope you guys understood. So 25th sum, the semi-vertical angle of a cone of maximum volume. So they are saying maximum volume and slant, given slant height, which is L is given. This is h and this is r. Therefore, all that you can write here is L square is equal to h square plus r square. And you are going to write the volume of the cone is 1 by 3 pi r square h. You want h, which is root of L square minus r square, correct? So then therefore write here 1 by 3 pi r square root of L square minus r square. I told you to square both sides. The v square can be considered as z. 1 by 9 pi square r to the power 4 into L square minus r square. Bring it in. Keep the 1 by 9 and pi square out. L square r to the power 4 minus r to the power 6. You haven't differentiated it. So dz by dr, you converted it to one variable because L is a constant. Pi square is a constant. Only one variable is there. So dz by dr. Thus you get dz by dr to be 1 by 9, what is it, pi square, L square is a constant, 4r cube minus 6r to the power 5 is equal to 0. Thus you can equate this with this, 4 L square r cube is equal to 6r to the power 5, r square it will become, okay, and this is 2 and this is 3. So 2 L square is equal to 3r square. So root 2 L is equal to root 3r. So you can find out whatever you want. Suppose you want to substitute and find h, you need r. Yeah, you need r in terms of given L. So root 2 by root 3, if you into L. So substitute that here. You get h is equal to root of L square minus r square. What was r square? 2 L square by 3. 2 L square by 3. So it will become root of 3 L square minus 2 L square, which is L square, which is L by root 3. Isn't it L by root 3? Yeah. So what can we do now? This is my height. Can I substitute that here? H is equal to L by root 3, correct? And they want me to prove that it's tan inverse. Read the question. Tan inverse is to semi-vertical angle. So I need the opposite and adjacent. So I would prefer to write everything in terms of r. H, can you write it in terms of r? Yes. So h is equal to root 3, instead of L you can write root 3 r by root 2 into root 3, because this root 3 is already existing. I am substituting the value of L from this, root 3 r by root 2. So root 3 get cancelled, h is equal to r by root 2. So right here instead of this r by root 2, if you do that r by root 2, tan alpha is equal to opposite by r by root 2, thus tan alpha is equal to root 2, alpha is equal to tan inverse of root 2. Again you have to take the differentiated value. Where have you differentiated? Yeah, this part, and do double differentiation test, where you have L square, which is a constant, 12 r square minus 6 by 30 r to the power 4. You have to prove that this, you have to prove that this is again maxima. The question is maximum volume, so you have to prove that this is negative. Double differentiation test has to be negative. Now how to, you have to first differentiate. Have I differentiated it already? L square Yeah, I have differentiated minus 30 r to the power 4. How to find whether this is negative or positive? You already know L square, you know what, you can write everything in terms of r, so that it's done, or everything in terms of L. R square, L square into 12 into r square is 2 by 3 L, minus 30 into r to the power 4 is 2 to the 4, 3 is 9 L square, L square, L to the power 4, L to the power 4. I am just substituting for r and doing it. So now it's easier for me to compare and see 12 2s are 24 by 3 L cube minus 4 3s are 12, 120 by 9 L to the power 4. Therefore, definitely the answer will be negative only. That's all. You have to judge like that. And so then next sum is also over. Okay, I think time is up for my class. Okay, I can do one more sum. Okay, I can do one more sum, which is I'll do the 24th sum. Show that the right circular cone of least curved surface area, so I have to write from the left hand side. There's a cone, and given I have to write here, the given is volume. I will write on the right side. Volume of the cone is 1 by 3 pi r square h. Least curved surface area, not total surface area, just pi rl. Curved surface area is pi rl. Again, you can't have two variables, you have to write one in terms of the other. You can only write what is h from this, which is 3v by pi r square. But you want L you know is root of h square plus r square, which is root of 9v square by pi square r to the power 4 plus r square. So, I am substituting that here, pi r into root of 9v square by pi square r to the power 4 plus r square. So, it's pi r root of pi square r to the power 4 is 9v square plus pi square r to the power 6. So, then we take the root out in the denominator, it will become root of 9v square plus pi square r to the power 6 by pi r square. So, pi and pi get cancelled, r and r get cancelled. So, you have one r here, you have to square both sides because it's maximum minima, you are allowed to do that, r to the power 6 by r square. Now, splitting this up, you can consider this as z. So, 9v square by r square plus pi square r to the power 4. On differentiating, 9v square minus 2 by r cube plus pi square into 4r cube is equal to 0. Thus, you can equate this with this, which is 18 v square by r cube is equal to 4 pi square r cube. So, r cube and r cube will become r to the power 6, and 4 and 9, this is getting cancelled. So, 9 v square is equal to 2 pi square r to the power 6. Thus, v square is 2 by 9 pi square r to the power 6, or v is root 2 by 3 pi r cube. The question is about, okay, what am I supposed to find in this question? Show that the right circular cone has altitude equal to root 2 times the radius of the base. Altitude equal to root 2 times the radius of base. I found the volume. Just go back, swing, go back, as I said, just always when you're stuck, go back to this. Instead of v, you substitute this v, which is root 2 by 3 pi r cube is equal to, what did you use right there? 1 by 3 pi r square h. 1 by 3 pi r square h, pi r square h. So, when you equate this, r square and r get cancelled, pi and pi get cancelled, the 3 and 3 get cancelled. So, root 2 r is equal to h is what you need to prove. Now, you have to take the you have to do double differentiation. You should take the differentiated value, which is here correct equal to 0, but you have to differentiate and see and assess whether it is going to be negative or positive. You know how to do that. Just continue like this, okay.